Here we go again. Let's call this a review. Digestive System Part 2. Not a lesson, just a review of stuff that we covered in class. And here's the big basic story. The human body is basically a tube within a tube system, where the alimentary canal or digestive system is the inner tube and the rest of you is the outer tube. We have some basic functions here, such as ingest and then egest. And along the way, something might be digested. The significant thing here is what you ingest is not necessarily something that you can take advantage of, and what you egest is not necessarily worthless. It's just that you didn't have the opportunity to break something down and absorb it. Also, please remember that the inner lumen here of the digestive system is the outer environment passing through you. So if you swallow a marble or coin right here, it goes in a marble or a coin, goes through a marble or a coin, and comes out a marble or a coin. It didn't change along the way, so it did you no good whatsoever. For you to be able to absorb something, things have to be small enough to get through the wall, and the small intestine is the main place where most absorption takes place. So if something comes in and it's too big to absorb, then digestion is important. So ingest, digest, egest. And of course, you have to absorb something before it has any benefit to you. So the expression is you are what you eat. In truth, you are what you ate, but not all that you ate, just the stuff that you were able to absorb. If we had to put a motto to this thing right here, it might be get small to the wall. The small part is take something such as a polymer or a macromolecule and break it down into a monomer or something small enough that can be absorbed. And a great deal of what we're going to be talking about is this process of breaking polymers to monomers, and that's going to be chemical digestion, and it's going to be dictated by the availability of enzymes in the proper environmental situation. Get small, polymers become monomers, so you can absorb these things. And then the wall. Even though you can absorb some materials through the wall of the stomach, the vast majority of nutrients are absorbed through the small intestine. And the small intestine is sort of designed in such a way to have wrinkles on wrinkles on wrinkles in a long, thin tube. The small intestine is something around the 15 to 20 feet long, depending on how you want to measure the thing. It has, it's about an inch in diameter. It has plicae circularis, which spirals its way down through the middle of the small intestine. Each one of those plicae is about a centimeter tall. You have one on one side, one on the other side that almost closes off the lumen of the thing, but it has a spiraling pattern. Also on top of the plicae, there are villi, which are basically absorption towers, and they're about 1 millimeter high. And then on top of the microvilli, on the villi, you have microvilli, which are, again, folds on the luminal surface of the cells that are the inner lining of the small intestine. So the simple columnar epithelium has microvilli, which together sort of look like a fuzzy edge, and they're called the brush border. Again, an immense amount of surface area down there in the small intestine for absorption's sake. Slide note over here, talking about things we already know. Of course, there are 6 major organs in the digestive tube right here, and those 6 organs would be mouth, pharynx, esophagus, stomach, small intestine, and large intestine. And it's basically one continuous tube connecting end to end, except for this strange little spot right here, the cecum, where the small intestine plugs in not exactly at the absolute end of the large intestine, but near there. We could take this convoluted tube right here and stretch the thing out and try to explain it as if it was a disassembly line, like a lot of books like to say. So we can talk about the mouth, pharynx, esophagus, stomach, small intestine, large intestine. Now, this isn't drawn to scale in any way whatsoever, but the intention is to show you that at the beginning right here, there's a wide space. Then there's a funnel-like structure, the pharynx, then a narrow tube leading to another wide space, the stomach, then a narrow tube leading to another wide space, the large intestine. It's significant that the stomach and large intestine have a little extra lumen volume because these are storage areas or areas where you slow down the movement of the food. And they're less for absorbing nutrients, so more for storage and final processing or storage and pre-processing, because the small intestine is where most of the action is going on. So 6 major organs of the GI tract: pharynx, mouth, pharynx, esophagus, stomach, small intestine, large intestine. 6 accessory organs: teeth, tongue, salivary gland, liver, gallbladder, and pancreas. The first 3 are associated with the mouth. The 3 pairs of salivary glands producing saliva and introducing into the oral cavity. Then there's the teeth, helping significantly with mechanical digestion, tearing, churning, chewing, and things along that line. Then the tongue, which is basically there to help mix materials up and form the bolus, which you will finally be swallowing down. So these 3 accessory organs associated with the mouth. These 3 accessory organs right here, liver, gallbladder, and pancreas, associated with the first section of the small intestine. The liver does not make any significant digestive enzyme. However, it does make bile, and bile is an emulsifier, which helps to take big blobs of fat and break them down to small blobs of fat. The gallbladder doesn't produce anything whatsoever. Instead, it can store excess bile and help concentrate it so that it can be introduced into the food when it's needed in abundance. The pancreas, however, lives up to its name, a pan, everything. It makes sodium bicarbonate to help neutralize or buffer some of the acidic chyme coming from the stomach, but it also makes major enzymes for each 3 of the calorie-carrying nutrients. So there is a digestive enzyme for carbohydrates, that would be amylase. There's a digestive enzyme for proteins, that'd be trypsin in our short list. And then there's one for fats, and that would be lipase. So again, these 3 accessory organs associated with the small intestine, having 1 or 2 openings into the small intestine. For processes right here, this is a bit extensive, but we start off with the idea of ingestion. Just put it in your face. Okay. Propulsion. We said propulsion can be divided into swallowing and peristalsis. And way down here, we mentioned how swallowing is accomplished using skeletal muscles. So therefore, you do have direct conscious control over it if you're thinking about it and you're conscious. So skeletal muscle is associated with the mouth, pharynx, and the upper 1/3 and a little bit of the middle 1/3 of the esophagus. So there is potentially a voluntary action. Peristalsis is the one-way motion, pretty much, of the food material from about the middle section of the esophagus, definitely the lower 1/3, and then all the way through the rest of the system to the very, very last, where there's a little bit of a skeletal muscle again in the external anal sphincter. So when it comes to propulsion, swallowing with skeletal muscle, potentially voluntary and conscious. Propulsion with smooth muscle, it's part of the autonomic nervous system, and you do not have direct conscious control over it. And so many more things we said about that in lecture. Well, let's go back to the quick general review right here. Let's compare mechanical digestion to chemical digestion. Here's a strange analogy. In mechanical digestion, what you do is you take a big chunk of something like starch, and you break it down to small chunks of starch. The size of the clumps is smaller, but the chemistry is the same. Starch, starch. But in chemical digestion, you use enzymes to break these molecules into different molecules. So starch could be attacked by amylase, the starch molecules be broken down, and what you release right here is maltoses. So in chemical digestion, molecular bonds are broken. In our story, enzymes are involved, and the original material is broken down chemically into another kind of material. But with mechanical digestion, again, what you had at the beginning, you have afterwards. These are just smaller pieces with greater surface area, and of course that does assist with all the other processes that happen later on. Greater surface area makes it easier for enzymes to work. Mechanical digestion includes things such as tearing and biting and chewing and churning, and it also includes dissolving. So if a sugar cube dissolves in the saliva inside your mouth, it was sugar as a cube, it's sugar now in the saliva, so that was mechanical, not chemical digestion. Bile also fits in this story right here because bile will take a big blob of fat and break it down to smaller blobs of fat. But it doesn't change the triglyceride into anything else but smaller chunks of triglyceride. Real quickly right here, again, when it comes to absorption, again, we said absorption mainly takes place inside the small intestine, only if the materials have been gotten down to a small enough size. And then elimination is when you throw away, through the anus, the materials that you couldn't take advantage of because of time or lack of opportunity, because the enzyme wasn't there or something was in competition. Something happened. You didn't have time to break down the polymers down to the monomers that you really needed. Real quickly here, let's finish this review off with 6 nutrients right here: carbohydrates, lipids, proteins, minerals, vitamins, and water. The line right here separates the nutrients that have calories in it, dietary calories, versus those that don't. So carbohydrates, lipids, and proteins, there's a caloric count to these things right here. However, for minerals, no calories involved in its digestion, nor vitamins, nor water. So the analogy we like to use sometimes is like this is 3 different grades of gasoline for your car. But when you go to the gas station, you still have to stop and get water for the radiator, and you need air to get into your cylinder, so you need an air filter cleaned out and stuff like that, and you need oil for it to work. But the air, the water, and the oil are not fuels. These things right here are the fuels.